Yes, in the last video we dealt with the median, and the idea of the median can be briefly summarized as wanting to find a value that is approximately in the middle of the data. Or in other words, we want to find a value such that 50% of the data falls below this value and 50% of the data falls above this value. And we also saw that this sometimes works and sometimes does not, depending on whether the numbers are even or odd. And today we want to discuss how we can generalize this when we are not talking about 50% of the data, but about any number or any probability, for example, 25% or 75%. And this leads us to the concept of the p-quantile. A p-quantile is essentially the following idea. We are looking for a value such that a proportion of p is less than or equal to this value, and a proportion of 1 minus p, that is, the remainder, should be greater than or equal to this p-quantile. And yes, we want to take a look at that, and above all, we want to see which formula can be used to calculate such quantiles. To do this, we will look at an example. Let's take the following sample, which is already sorted, meaning from largest to smallest. And we plot this sample. We have a total of, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So the size is 10, and we know that it is an even number. So there is, as we remember, not a middle point. Thus there is the median, which is exactly between the 5th and 6th values. And what we need to do is 2001, so we have to add the 10 here, plus the 12 and divide by 2. That's how it was with the median. Now we do not want to look at the so-called 0.5 quantile, but rather we want to examine a value such that 25% of the values are less than or equal to this value, and 25% are greater than or equal to this value. And we call this the 0.25 quantile. And now we can take a look. We have 10 values. So 10 times 0.25 is exactly 2.5. That means there are somehow 2 possible values to consider. It could be the second value, but if we take that, let me use a color, so it could be the 4. If we take the 4, we see that only 2 values are less than or equal to 4, which are only 20% and 80%, respectively. Even 90% are greater than or equal to this value, namely 9 out of 10. And now we see that if we look at the 5, we have 3 values, the 2, the 4, and the 5, which are all smaller than this value. These 3 here represent 30%, and those that are greater represent 80%, which is good. This means that the 0.25 quantile is actually this third value, namely the 5th. And the same can be done with the 0.75 quantile. So if you want to know that exactly 75% are less than or equal to this value, and at least 25% are greater than or equal to this value. So what did we do? We took 0.25, as we can see here again, we multiplied 0.25 by 10 times n, so we took n times p, and then we rounded this value up to the third, and that is essentially the index that tells us what this p-quantile is. And now we want to take a quick look at this as a formula. So we assume we have our ordered sample, x to xn, and we have this value p. Then we can determine the p-quantile as follows. By the way, we write this as x tilde p. So x tilde p, and we call it the p-quantile. And then we will take a closer look at this use and. So we calculate n times p, which in this case was 10 times 0.25, and that did not yield a whole number. It was 2.5. What we then do is round up, which becomes 3, and that is nothing other than what is stated in this index. Here it is a bit more complicated. It says n times p, and then there are these brackets. Yes, these brackets, those are rounding brackets. They round down. One could also round up directly, but we have written it down a bit more complicated here. So we round down, which are called Gaussian brackets, and then we add 1. This means we round 2.5 down and add 1 to get the third value, and this is how we usually obtain the p-quantile accurately when n times p does not yield a whole number. In other words, when the whole does not work out. If it works out, what we actually do is similar to the median. We look at two values, namely xmp and xmp plus 1, and then divide that by 2. So, this is again analogous to the situation where it works out. We would take one value to the left and one value to the right. Let's take a look at this again as an example. I will go back once more. Imagine that we are now looking at the 0.2 quantile. So, let's consider the 0.2 quantile. I will do this here in a new color. We would have 0.2 times 10, and that would yield a whole number. Yes, that would be the second. And what we then need to do is take the value in between. Because if we take this value in between, namely x plus x, 2, then we know how many values are smaller than that, which are exactly 2, so 20%, and how many values are greater than that, which are then exactly 80%. And that's exactly how we wanted it. We wanted to exactly divide the data into the first 20% and the first 80%. Well, it's a bit more complicated, but it's relatively similar to how we calculated the median. What do? They arrange the sample in order, then check if n times p results in a whole number. If it does not, they take n times p and simply round the number up once, thus obtaining the correct index. However, if it results in a whole number, they take np1 and the value at np and the value at np plus 1 and average them just as they did in the case of the median. So those are p-quantiles. And in the next video, we will look at what the so-called sample variance or sample dispersion means. Until then.